And if I asked you for the cosine value for 0 pi, it's just the x-coordinate. So the cosine value for 0 pi is 1. The sine value is 0. So don't forget those cosine and sine values are just the ordered pairs. That's the beginning. Remember, the top of the unit circle is going to have an ordered pair of 0, 1. And remember, that's pi over 2. And then, of course, on the left, y'all, this is plain pi. And that is -1, 0. So the cosine value is -1. The sine value is 0. At the bottom, this is 3 pi over 2. And we know this is 0, -1. So guys, if I have traced all the way to the bottom, I haven't really traced the full circle. So remember, when you go back around, you went 2 pi, and you're back at the same thing. Y'all, if I keep tracing around this circle, I'm going to run into repeats. So we have unique values for sine and cosine from 0 pi all the way around to 2 pi. If I keep going, I'm repeating myself. So these unique values for 2 pi, that's called a period. And a period is just a cycle of something before it repeats, before it starts repeating over and over and over again. All right. So from here, we're going to pick these pieces apart. We're going to look mainly at sine. And then over here on the left side of my paper, or the right side of my paper, I'm going to mainly look at cosine. So what I'm going to do is I'm going to draw an input and output chart for both of them. All right, over here for sine, I'm going to focus on sine for a few minutes. Over here for sine, I'm going to analyze the sine values based on the radians. We're going to start at 0 pi. The sine value for 0 pi is 0. Let's look at the top of the unit circle, pi over 2. What's just the sine value? What's the sine value at the top? And then the left side of the unit circle is, of course, just 0 for sine. The bottom of the unit circle, 3 pi over 2, that's where sine reaches its lowest value. The lowest sine ever gets is -1. And to complete that period, to go back where I started at 2 pi, I know that sine is 0. So let's kind of look at what we just did. We have inputs and outputs, and we're going to put that on a coordinate grid. The x-axis are going to be the inputs in terms of pi, radians on the unit circle, angles on the unit circle. The outputs are going to be the sine values. Notice the biggest sine value ever gets is 1. The lowest the sine value ever gets is the -1. I'm going to graph this. So look how I draw my x and y axis. So if you notice, my x-axis is only focusing on the positive values right here because these pi values are positive. And my y-axis, I drew it kind of short because I really just need to show one place above and one place below. So let's plot these as ordered pairs. So I know this is 0 pi right here. And the output is 0, so the graph is going to start right here. I'm going to draw a dot. And then pi over 2 and pi and 3 pi over 2 and 2 pi, let's just kind of space the rest of these out. So that's going to be pi over 2. Here's going to be pi. We'll say 3 pi over 2 is right here. And then 2 pi is going to be here. Let's go ahead and label these increments that we created. Just space them out visually, guys. Space out 4 increments the best that you can, and just label them pi over 2, pi, 3 pi over 2, and then 2 pi. All right, so back to pi over 2. Pi over 2 is where sine reaches its tallest point on the sine wave. So this is going to be at +1 right here. Now I'm at regular pi. Regular pi has an output of 0, so this is going to be on the x-axis. 3 pi over 2 is where it reaches its lowest amount of -1. So here's -1 right here. I'm going to kind of cover up that 3, but that's okay. And then it reaches its back to the middle at 2 pi. That's all I need to show because everything else is a repeat. So the sine wave, like your parent function sine wave, is going to look like that. So remember, there are 6 waves that we're going to look at. And it's really easy to get confused unless you know the shape of the graph. So you guys just drew the parent function. Their parent function looks like this. F of x equals sine x. And y'all, sine always starts in the middle, then it goes up, then it goes down, and it always ends at the middle. Draw that shape. That shape's required. You have to draw those shapes on tests and quizzes. Sine always looks like a sideways S. Starts in the middle, stops in the middle. All right, let's take a look at what's going on over here at cosine. All right, so again, my top row is going to be just like this. So 0 pi, pi over 2, plain pi. 3 pi over 2, and then wrapping it up at 2 pi. But my outputs are completely different. So if I go up just a little bit, ooh, goodness. So at 0 pi, we just want the cosine values. So at 0 pi, cosine is 1. At the top of the unit circle, cosine is 0. On the left, at plain pi, cosine is -1. At the bottom, cosine is 0, but again, when you go back to the beginning, cosine is 1. So if you notice, it's kind of similar. It does get the highest value of 1. It has the lowest value of -1, but they're not identical, which means their shapes are different. This started with 0, this started with a 1. I'm going to draw a little x and y axis. It's going to look just like this. I'm going to have a short x-axis, a long y-axis, a short y-axis, a long x-axis. My increments that I'm going along the x-axis are still the same. So 0 pi over 2 pi, 3 pi over 2, 2 pi. All right, looking at this, it does start at 0 pi, guys, but cosine starts one place above the origin. So cosine is going to start right here. Sine started on the origin, not cosine. So it starts at the top, then pi over 2 is just 0. Pi is going to be -1. 3 pi over 2 was at 0. And then remember, 2 pi is where it goes right back to the beginning and at +1. So this is the shape of a cosine wave. And that's the parent function. So f of x equals cosine x. And guys, so important to me. It reminds me of a horseshoe. Cosine starts at the top, it goes down, then it ends at the top. Sine waves look like sideways S's. Cosine looks like horseshoes.